George Passow, how do you feel about internal combustion engines and emissions?
I feel great about internal combustion engines and emissions.
Thank you.
No problem.
Automobiles come in all shapes and sizes. Some have 4 wheels, some have 3 wheels, and some only have 2 wheels.
But what do these automobiles have in common? Sure, they get people from A to B, and sure, they all have wheels, but what about underneath the hood, or fairings?
Engines. All these vehicles have 4-stroke internal combustion engines. What does it mean to have 4 strokes, you ask?
Check out this animation. 4 strokes refers to the intake, compression, power, and exhaust strokes that occur in each cylinder. Slowing it down a bit, can you see all 4 strokes that take place now? Hydrocarbons are commonly used as fuel, and when mixed with air, it is highly combustible. Hydrocarbons power our internal combustion engines.
So hydrocarbons and air go into an engine. But what comes out?
That brings us to emissions.
Why should we care about emissions? What is in exhaust?
Well, engine exhaust emissions would ideally contain only carbon dioxide and water, but other things such as carbon monoxide, nitrogen oxides, unburned hydrocarbons, and ozone are also found in emissions.
Oh, wow! Look at all that junk coming out of there. Where does it come from?
Well, follow me, Fred, into the lab, and I'll show you. This is our engine dyno. Here we run controlled experiments on engines to collect raw data that we later analyze.
Oh, what does the recorded information tell you?
By comparing combustion and emissions data, we can draw conclusions that allow us to predict the engine's performance. Here are some graphs from our recent experiment where we varied air-fuel ratio at a constant load of 10 foot-pounds and at approximately 2600 RPM.
Oh, well, it looks like there's a clear trend between air-fuel ratio and exhaust temperatures.
Why, yes there is. That is a very good observation. Notice that leaner fuel mixtures produce elevated exhaust temperatures. NOx emissions are only produced at high combustion temperatures. Here we can see that air-fuel mixtures that result in higher temperatures produce more NOx.
Oh, and you mentioned before that carbon dioxide is part of the ideal chemical reaction in combustion engines. It looks like in leaner mixtures there's less CO2 produced. Is that because there's less fuel and therefore not enough carbon for the air to bond to?
Precisely. And for this graph, we can see that higher levels of carbon monoxide are produced with richer fuel mixtures.
Oh, cool. Well, let me guess this one. Excessively rich and excessively lean fuel mixtures result in more unburned fuel because there's either not enough air to burn all the fuel or there's so much air that the fuel is too spread out to effectively combust.
Exactly. You're really getting this. You should be an engineer. Having a good understanding of this information allows us to tune engines for optimal power output as well as minimize emissions output.
Well, thanks for showing me all that, Ryan. That was really cool.
No problem.